Bismillah ar-Rahman ar-Rahim. Today we will talk about one of the most important topics in chemical management, that is measurement units and chemical concentration, and how we express the chemical concentrations. First of all, let us introduce to system units. We have in measuring in our life, we have different system units, especially when you read safety data sheet or when you read from various books or sources. For example, we have international system, or what is also known ISO system. And this system, this system is applied in most of the world country, and in our Arabic country, I think we use it. International system is based on the metric system. That means we use meter to measure the length, kilogram to measure the weight, seconds to express the time. Sometimes you call it meter MKS system. Also for shorter dimension, instead of meter we use centimeters. Also this international system. The weight, instead of kilogram we use the gram, and second, the time is the second, and hours we use hours. Of course, in the world there are other systems, US and UK systems. They are almost same but with different variations, especially with the volume, the gallon. In the United States, they use instead of meter, they use the foot for length. They use inch for smaller length. They use pound instead of kilogram, and ounce. They use time, although they use second. Also, they use mile for longer. Yeah, in international system, I forgot also to mention that we use kilometers per for longer distance. For example, when we measure distance between Abu Dhabi and Dubai, we say it's almost 100 kilometers, 120 kilometers. So this is the two major systems used for measurements. Also, let us introduce to a symbol or type of measurement. We will introduce to standard SI units. The length we use meter, the symbol M. Mass we use kilogram, the symbol kilogram. 1 kilogram means 1000 gram. Time we use second. For electric current we use ampere. For temperature we use Kelvin. Amount we use mole. For luminous intensity we use candle, the symbol CT. For noise we use decibel, dB. Also there are prefix that help us determine the amount. For huge amount, for example, we have a meter, but we have centimeter. Centimeters means each 1 meter equal 100 centimeters. 1 meter equal 100 centimeters. So 1 centimeter is 10 to the power of minus 2 millimeters, because 1 meter equal 1000 millimeters. 1 meter equal, I will write it here, 1 meter equal 1000 millimeter. That means if we have 1 millimeter, that means it's 1 to the multiplied by 10 to the power of minus to the power of 10 to the power of minus 3 of the meter. We have the micro, means 10 to the power of minus 6. Then we have the nano. This after the digital revolution, we use the nano. 10 to the power minus 9. We have pico. This will known as femto and otto and zepto and giotto. On the other hand, we have kilo. We said kilo means 10 to the power of 3. Mega, 10 to the power of 6. Then we have giga. Then we have tera. Then we have beta. It's just for your reference. I highlighted the most common prefix used in our life. We have kilo, mega, and giga. This is a simple. K, kilo, mega, megagram, megapixel, megabyte, kilopixel for resolution, something like that. Santi, milli, micro, this is the prefix, and nano, and this is the prefix. Nanometer, micrometer, millimeter, centimeter. We put, for example, centimeter, we put cm, centimeter. Millimeter, we put millimeter. Micrometer. Okay, and the most common also, as you know, the most common other British unit, 1 foot equal 12 inch. This not for you to remember, just for your knowledge. I know now you can use it, you can Google it, but it's good to know the theory behind the things. 1 inch equal 2.54 centimeter, 1 foot equal 30 centimeter. We have the gallon, we have US gallon, and you have a UK gallon. US gallon 3.78 liters. We use the liter in SI units to express the volume. We have a UK gallon that equal about 4.5 liters. This is for your information. 1 mile equal 1.6 kilometer or 1,609 meter. 1 pound equal 454 gram. This is for mass. Sometimes, as I said, if you want to convert from one system to another, you can use Google simply. Yeah, you can ask Google, but I will just introduce to you to some simple method how to use it. Suppose we have this, you have this dimension, you have 500 feet. How many meters? We have been asked how many meters. If you have 500 feet of cable wire, how many meters? How to transfer it? You know, one of the simplest way is to use this option. We know. I write it. Just I wanna let me make. I wanna highlight it to 20. This 500 feet. How many meter? You know, just to transfer it from. Convert from one unit to another unit, we know that, for example, I put here 1 foot equal 12 inch. So if I know that I write 500, I want 500 feet, I want to know how many centimeters, I put it in I put it like that, then I'll divide it. I know that 1 foot, I put it, the foot here is dominant في البسط. I put it in في المقام. 1 foot equal, I know that from my knowledge, for example, 12 inches. 1 foot equal 12 inches. So foot with foot, you can remove foot with foot, because so if you multiply 500 by 12, that means you got your answer by 6,000 feet, 6,000 inch. And you know, for example, from your knowledge, that you know 1 inch equal 2.54 centimeters. So we remove inch with inch. So if you multiply 600 with 2.54, you got your answer in centimeter. Then you divide it to 1 meter. You know that each 100 centimeters equal 1 meter. So what you got here, you divide it by 100, so you got your answer in meter. Let me make the calculation. 6,000 multiplied by 2.54, you got 15,240 centimeters. You divide it by 100, so you got 152.4 meter. This, if you go to Google and you ask him to convert 500 feet to meter, you got this number. This just, of course, I made it using the longest way, but this is how it goes. Now we have another term, you use it in chemistry and hazardous substances. We use the concentration, we use the ppm, part per million. This part per million is a unit of measurement. It's used to describe the concentration of one substance in another solute in a solvent. For example, if you have a cup of water, you dissolve 5 gram of salt in this cup of water. You want to express the salt concentration in the water, so use the ppm. You dissolve sugar in water. You want to express the concentration of sugar in the water. So this is the ppm, part per million. Usually it's for example, I will let you just one moment. Let's continue. Part per million, what does it mean? That means, suppose UAE population 10 million, number of population United Arab Emirates 10 million. For example, if we have rare diseases that cause illness for 50 persons per million, so that we have 50 part per million. That means we have 50 persons got this illness due per million of population, per 1 million of population of UAE. So, for instance, we expect we have 100 ill people because we have 50 persons per 1 million, and the population number in UAE is around 10 million. So we have 10 million by 50, that means 500 ill persons. So this is the part per million. So part per million of part others. So from when we got this, we have, for example, you have 1 liter of water. 1 liter of water, the volume, 1 liter, the weight is 1 kilogram. 1 kilogram. For example, 1 liter of water, 1 liter of water, weight 1 kilogram. And 1 kilogram, how much equal? Kilogram, 1,000 gram. We agreed, 1,000 gram. And 1 gram equal 1,000 milligram. So 1 gram, but 1 gram equal 1,000. Let us make here 1 gram equal 1,000 milligram. So we have 1,000 gram multiplied by 1,000 milligram. That means 1 million milligram. We agreed that 1 liter of water equal 1 kilogram. 1 kilogram means 1,000 gram. 1,000 gram means 1 million milligram. You can set it. So if we set part per million equal 1 milligram per liter. 1 milligram per liter. Let's say it 1 milligram. Here again, it's per liter. Yeah, instead of liter, we put 1 kilogram of water, 1,000, we put 1 million milligram. Of water. So it's the ppm. We express the concentration of salt. I said if you have 1 milligram of salt, you dissolve it in 1 liter of water. That means the concentration will be 1 milligram of salt dissolved in 1 liter of water. That means 1 milligram per million milligram of water. That means 1 ppm, part per million. 1 million per million of water. This is the ppm. It's commonly used to express the concentration solute in a solvent. One material in another, one substance in another. So milligram per liter. Okay, if we multiply by 1000, we will get 1000 milligram. That means 1000. If we multiply here by 1000 to 1000, we will get 1000 liter equal 1 meter cube, 1000 milligram equal 1 gram. So ppm also it's 1 gram per meter cubic and 1 milligram per liter. It's same. Why? Because if we multiply here by 1000, multiply by 1000 over 1000, nothing will change. But if we get 1000 gram, that mean 1 gram, and 1000 liter means 1 meter cube, 1000 milligram. That mean, sorry, we multiply this value. I'm sorry. So if we multiply 1000 milligram, we will have 1 gram. If we multiply 1000 liter, we have 1 meter cube. Sorry for that. So this is part per million. I will stop here this lecture. I will give you a question in the final exam how to express the concentration if you dissolve, for example, 5 milligrams of water. Express the salt concentration in ppm if you dissolve 3 grams of NaCl in 1.5 liter of water. So 3 grams of NaCl is dissolved in 1.5 liter of water. Express the concentration in ppm. ppm we said it's equal milligram per liter. So 3 gram, how to solve it? I think 3 gram of NaCl equal 3000. 3 gram of NaCl equal 3000 milligram of NaCl. So to express the concentration, I divide how many milligram per liter of water. So the concentration in ppm, NaCl concentration in ppm equals, I find the quantity, how much I have, 3000 milligram of NaCl dissolved in 1.5 liter, 1.5 liter of water. So divide 3000 milligram by 1.5. That mean equal 2000 ppm. So this is the solution. Okay, such question will be at the final exam. Please keep your eyes open. Thank you.